Hello! How is everybody? We're gonna do a nice little chill game dev stream tonight. We're gonna program some things. So let's start with let's start with seeing what we actually have. So this is our initial progress so far for our tower defense Antarctic strategy game, where you play as a top hat, which you can vaguely see moving around over here. I guess that's sticking to grid. It probably is. Anyway, the idea is we're going to summon more snowmen strategically. What?
Why is it so blurry?
Is it blurry?
On my screen, everything, including you, is very blurry.
Oh, check your in the gear icon. Check the quality.
Okay.
Make sure it's maximum.
Gotcha.
It is a little blurry, but it shouldn't be. But I shouldn't be blurry. So tonight's plan is a lot of things, actually. For one thing, we have to have an actual game loop of, like, we have to be able to gather resources and spend those resources instead of just being able to freely spawn snowmen however many we want. Which, although hilarious, is overpowered. Plan is that we'll get to that eventually. Have a lot of tabs open. I have one tab visible on screen.
You use Windows and a lot of it.
Oh, yes. Those are windows. So let's see here. We are going to... I kind of want to start with being able to... Is that the actual size of this? Oh, it's just centered. Oh, no, it's being pushed over by the text. Ah, that would do it. Because I just put this as a span. No, that's not it. What is it? Float left? No, that's not what I want either. What do I want to do to make this not do that? Oh, it's because the canvas is like that. So display block. That does help. Okay. Change the canvas display to display block in the CSS one, first of all. Canvas. Oops. Display block. That will help. Alright, so we want to do pathfinding tonight. Specifically, we want the penguins to be able to tell where they're supposed to go in the quickest way they can. Starting a programming project, that'll be fun. So first off, we actually need to add something to our artwork. We need to have a wall of some kind. It's a barrier made of snow that the penguins cannot pass through. So just some kind of snow barricade. Also, while we're at it, let's fill this in. Well, that's some Animal Crossing music. I recognize that. Oops, not like that. A little bit here, a little bit here. There we go. Snow puffs. Now, I'm gonna make sure that we've got the right grid area. Okay, so a wall. here. All right, so there's our square. So I think this will be probably blue, and it should extend most of the way to the edges. Maybe not fully. And I don't really know what it should look like. Something like this. Hey, Snarky. This is kind of rounded, maybe. So this is supposed to be a like a fortified wall of snow. Nah, it's too small, isn't it? Okay, I can see that working. Maybe, maybe. Where's that one song from, hang on. Where's that, like, it was Paper Mario, Origami King, Coffee Shop Music. That's the one. Extended, yes. Hey, Casual. What a jam. So let's kind of do like kind of half shading. Tricky. A snowman that shoots in all directions. Currently they all shoot in all directions. Tower defense, yes. That is the plan. Does this look like a wall? I mean, almost. It almost does. Looks like a sink. I guess so. I don't know exactly what I was going for in the middle there. Let's just remove that for now. Hammer tower. Don't know what that means, but okay. It's in the ideas now. Because I don't want to use a lot more colors is the thing. I want to keep things as monochrome as possible. What else? What else could look like a, I don't know, like some kind of blockade with toilet paper. Like this is like vaguely a very shallow like cylinder, like a rounded rectangle. Doesn't look all that great though, admittedly. Doesn't look all that great though, admittedly. Why do I hear myself? Why do I hear myself? Oh, I see why I hear myself. I've got so many. So Photoshop has a ton of shortcuts, keyboard shortcuts, but so does Twitch. And by hitting M to change to the selection tool, I actually had focus on the chat window, so M was unmute on my. A tower that shoots a circle of pellets around it, but shoots less than the regular snowman. Possibly. I don't know if aim should be a thing. Like, currently, snowmen always have a specific target they're shooting for. The idea of just kind of vaguely aiming towards some penguins, we could do that. Kind of an area of effect sort of thing. Icicle, that might be a little bit better. Go for a cone instead. Let's see what would have. Tricky though. Like a single cone. Oops. does it really read that the penguins have to go completely around this? A dead snowman. Ah. See, I want this to be like a simple base version. An ice cube. Ooh. So instead of going the straight on... Okay, consider this. What if eventually these walls actually kind of connect and they tile in some way? So you get something going on like, wait for it. So you get something going on like, this is gonna look better in a second, I promise. You get something a little bit more like this eventually, where it actually reads as a single wall. Like when you get multiple walls built, they like join. Does that read more like a wall at that point? Different types of penguins with more health. Yes, probably will be multiple penguin health types. That looks okay. So I think that might be the piece we were missing, was we need to make sure that the walls like join up. So it'll kind of like, yeah, they'll tile together. That makes this read a lot more clearly, doesn't it? It looks a lot more like a solid object now. It's a nice wall. Good. Okay. Now, here's the thing. The tiling, that's for another day. Right now, we just need a tile. Let's throw that in here. Let's just save that as a PNG. Art. I'm just throwing every asset in the game in a single PNG for now. Spawns from the back. As far as spawning position, I don't know where that's going to be yet. Like, I don't know if the penguins are going to have like a set starting point in every map, or maybe multiple spawning points, or if it'll just be some random position from outside of the arena. All right, so let's add a wall element. Are walls going to take damage? I don't even know if walls are going to take damage. Snow wall. Candy cane trees, maybe, or just big and pile. There will be piles of snow, both big and small, that are going to be kind of your resource nodes, where you can collect more snow currency. Polar bear we could do it polar bear. It's a little bit wrong pole, but I think it could work. Wait, is it? Do they have polar bears? I don't know. I don't know much enough about the Antarctic. So let's see here. We want to extend snow wall. Well, that's not going to get confusing. Which will have a tile X and a tile Y. Oops. Tile X, tile Y. Tile X, tile Y. Gosh, TypeScript does that a lot better. It's going to use tile index 8. Can make some concepts. Why don't you have different maps? Yes, there will be different maps. I think they will be... I've fiddled around with the idea of randomly generated maps, but I do like the idea of like hard-coded, here's level 1, here's level 2, here's level 3. Though maybe you have access to multiple maps initially. Let's see here. X and Y. Like so. Update. There is no logic. Snow walls do nothing. I haven't listened to it, but I did see that you did post something there. Okay. So a snow wall. So now we need to make sure that we include that in our list of things that the code has access to. Next, we need the ability to actually do something with the snow wall. Even make your music OC thing look cooler. Nice. Okay, we're gonna have action 2. Which actually, oh, this is interesting. Do I even need to define these? I don't think I have to define these since this kind of does the trick. Key state. Yeah, that does the trick, really. I guess I'm just kind of defining these just for clarity for myself, but it's not necessary that I even list these out here. We make a fish as a mini enemy, so it's like a slower but faster enemy, but then you just have to have water flowing to the tower or just have them float. It's true. That makes pathfinding a little bit more interesting. Okay, so we have an action 1 already defined. We're adding an action 2. Ooh, this is gonna be difficult. Faster turn into wood. That's a good question. Ooh, this is tricky here. Instance of snowman. See, I'm looking for, is there something built on this tile already? Okay? Which is tricky because, like, what's the easiest way to do that so I don't have to define every single element? Maybe I just say not instance of player. Because, no, because the penguins, well, I don't want to build on the penguins. What would the penguin's death animation look like? That's a good question. So we're going to say existing sprites. Existing sprite at location. There we go. That does the trick right here. And then we can just say if there's not an existing sprite at location. So we can move this here. We can clean this up a bit. There we go. That's much cleaner. And now we can say if key state action 1. And we're gonna else this for now because I don't want to accidentally do both things. Else if key state action 2, which is basically saying if you hit key number 2. We might give these better names. The whole interface in general might change a little bit at some point. I don't know about the hotkeys and everything. Okay, let's see if that works. Here we go. Can we add a snow wall? Yes, we can. Ooh, look at this. Now, right now, the penguins do not respect walls, and they will just walk right through them. But we have the ability to spawn walls now, which is a great start. One thing I do note is the hat goes behind the wall, which I don't like. Luigi hat on the tower, so it will win by doing nothing. I mean, basically, that is the idea, is the tower wins by doing nothing. Alright, we need... layers? Z-indexes, maybe? This is going to be a little bit a little bit hairy. How best to handle which sprite gets drawn where? That's a good question. An accidental mistap, perhaps. Let's not deal with that right now. But eventually we want to have some kind of priority of draw these sprites, then these sprites, then these sprites. Okay, now for tonight's big project. Do I want to have a sprites folder? I might need a sprites folder at this rate. Hat, penguin, snowball, snowdrift, snowman, snowwall. Which means now I gotta update all of these to be sprites slash. There we go. That wasn't too bad. Make sure it still works. Okay, good. We're good. Alright, now, tonight's big project is pathfinding. It's a good creation. Let's just call that pathing. All right, I'm gonna look at it just for you. Discord. I see that typical is still on the I'm a real human shtick. Fight or flight. Map idea. Water's in places where you can't play. Yes, that is an excellent point, Casual. Water, the special thing there is that you can't place towers there. But presumably the penguins can mess around with the water. Like, the penguins can swim through water. Yeah, I do need to also have something that the penguins can't pass over, but you can still build on, maybe? Or maybe the idea is, like, you just have to do it yourself. Like, if you want the penguins to go a certain way, you have to build that. We're not building it for you. All right, pathfinding. Oh boy, this is gonna be a thing. Hello, Jen. You're just in time for pathfinding. All right. Well, not now, but okay. So, now that we have the ability to spawn these little walls, the penguins need to respect that. Oh, she's okay. Gwen now also. All right, this is going to be either really inefficient or it's not going to matter because of the size of the map. All right, break out the paint. All right, guys, here's the plan for the pathing. So, the whole area is divided into a bunch of squares. All right, so you got a square, a square, a square. Is going to take a bit. Squares, squares, and just for good measure, go ahead and get some more squares in there. All right, so the area is squares. Everything is squares. Like how the penguins walk on water. They will swim eventually. All right, so here's what we do, guys. Here's how we're gonna do the pathfinding. We're gonna have the tower, all right? The tower is our big old candy stripe goal. That's where the penguins want to get. The penguins could be anywhere, all right? Let's not assume that we know in advance where the penguins start, okay? That's an important piece. We don't really know where the penguins are going to start. All we know is where the tower is. So, here's what we're going to do, all right? we're gonna tell the code, start with the tower, okay? Don't look at anything except the tower to start with. Then, look at all surrounding cells. Ignore... Actually, let's go ahead and fill in some with a little snowdrift here. Bloop. Just for clarity there. All right, bloop and what else? That might be the only one. Okay. Yeah. And bloop. Sure. Okay. So, let's assume that every penguin can move diagonally. Do we assume diagonal movement? What do you guys think? Do penguins move diagonally? It doesn't look like they should be able to move diagonally, honestly. Oh, I'm gonna have to have art that extends outside of the reaches. Yeah, that's the tricky thing, is that if they can move diagonal, then they're just gonna be sliding through these gaps right here, which means that building a wall is gonna require a lot more wall. This is gonna be tricky. This is a big design decision, but actually it's not gonna be as terrible if we want to change it later because of how we're gonna build this code. For now, for the sake of this code example, let's assume that penguins only move orthogonally. That is, up, down, left, right, no diagonals. Orthogonal only. So here's what we do. From our candy stripe tower, we're gonna look at all available spaces where penguins could move from the tower. The better you maze them, the more efficient your towers can be. That's true. Orthogonal is such a good word. So what we're gonna do is we're gonna grab all the available places they can move. We're gonna start by calling our tower 0, and then all orthogonally adjacent cells become 1. Now, the next step in the code is until all cells are filled or unavailable for whatever reason, then look at all of the existing 1s and do the same thing, but for the next number up. So this 1 right here at the top is going to look at all orthogonal cells that are not already numbered and are also available for movement. So it's going to say, I can move here, so I'm going to make that 2. I can move here, so make that 2. I cannot move here. I cannot move here, because that's already got a number in it. I'm done with this 1. This 1, check, we're done. This 1, we're not done, because there's 1 right next to it. Now we're done. And then the last 1, gotta fill in this 1, and we're done. And repeat. So you go 3, 3, 3, 4, 4, 4, 5, 5, 6, and we're done. All right, so all that's gonna do is that's just gonna fill the map with numbers out to some certain distance that I don't know how far out we need to go. Like, do we want the penguins to be able to go all the way out to sea and be pathfinding from there? Maybe we do. So now I've done these numbers. What does that mean? Well, now I'm a penguin. I'm doing my code to figure out where I need to go next. I am right. Where am I as a penguin? I am right here. Okay? I'm here. I'm on a 4, and now it's my job to figure out where do I go next. Rather than do an expensive calculation of basically this whole A-star pathfinding thing, instead I'm just gonna say, hey, I'm on a 4. Let me look at the map to figure out which of the adjacent cells is a 3, if any. And if there's multiple, coin flip, probably coin flip if there's multiple 3s. Well, it looks like there's only one 3, so from that, we gather, as a penguin, if I'm on this 4, I move north to the 3. That's it. And then from the 3 to the 2, to the 2, to the 1, to the 1, to the 0. And there's that is how we get this big, this map of penguin directional flux. This is our penguin flux map. It tells a penguin, no matter where they're standing, the penguin will know where to go. Because we might have some things later on in the game that, like, just move penguins around into weird spots that may not be in the critical path, and the penguins are going to have to know, how do I get out of this spot? All right? And so, from these numbers, there is a defined mesh of where do I go next. Now, we might take the pre-baked calculation a step further and not just save the numbers to our pathfinding setup, our navigation mesh. This is effectively a nav mesh. But we may also store the directions. So instead of just storing the number 4 here, we're going to store a list of which valid directions there are. This one, up. This one, up or right. This one, you can go up or left. And so that way we don't even have to look at neighboring tiles anymore. We just tell the penguin, hey, here's which ways you can go. Do it. Do the thing. That's our plan. That's how these penguins are going to find their way around. That's what we're going to program, is this really cool diagram here. So, let's start with something. I don't know. We're going to need some base items here. What are we going to need? A list of tiles? I don't think I want to do an actual array of arrays. Like, we could... Arrays of arrays look very nice for human readability. Whoops. But as far as making that into readable code, it gets to be a bit of a mess, because there's, like, indexes and sub-indexes, and, like, wait, was that the row or the column? So what we might end up doing is we might make each tile an object that stores a tile X, a tile Y, and its calculated distance, which is the numbers from our diagram, the black numbers on this diagram. And then finally, it's best route, which is a list of up, left, one of those. How will the penguins interact with the player themselves? I'm kind of thinking they don't. I'm kind of feeling like the player is more of a mouse cursor sort of interaction. In the same way that when you're playing an RTS, your mouse cursor does not get attacked by the enemies. Although that could be a very interesting concept. Hello, Turtle. These penguins are about to penguin. Let me tell you. Turtle, you better get ready for this. This is the diagram we've just made to describe what we're doing tonight. I hope you're ready for that. And I think instead of talking about things like up and left, we're going to represent that by actual numeric values. Like up would be x0, y, -1, and then right would be x1, y0. And so these objects represent the directions themselves. It's also clear now. Excellent. Okay, so this is going to represent a single tile, and it's also going to represent its current processing flags, like how far along we are in generating this navigation mesh, as we're calling it which makes it sound a lot cooler than it actually is. All right, so what are the steps in this process? First, we need to generate our list of tiles, and they're just going to be blank with just an X and a Y, and that's it. And we're going to have some way of determining which areas we cannot pass through. I don't think that'll actually be so hard. So let's see here. Let's start with a generate new mesh. I think we're not going to parameterize anything just yet because we don't know exactly what these are going to look like. So we're just going to start with some sort of width. You know what? We do have cell row count and cell column count, which represents our initial sort of but how far off screen, you know? Are the penguins just gonna bubble up from the water, maybe? Like, let's look at this. Like, right now, I just try and generate them at the far edges of the canvas. I don't even do that good a job of that. What if they sort of like there's ripples in the water, and then the penguins begin moving? So we can basically spawn in the ripples wherever we want. In which case, we probably only need to go out, I don't know, 5 tiles? Exactly. I think 5 tiles would probably be a reasonable distance. Oh, that's a great game concept, Snarky. The idea is that the enemies don't give themselves away until they make it to the shore. Let's see here. Absolute max X is going to equal our cell row count -1 divided by 2, which is to say, oh, but +1? If I've got 5, my middle one is tile 0, the ones next to it are tile 1, and the ones out there are tile 2. I'm looking for 2 if I pass in 5. So yeah, -1 and divide by 2. And we're gonna add 5. Adding 5, well, let's make that a parameter. Let water, num water tiles to mesh. To mesh. I don't think mesh is really the verb here in a navigation mesh, but whatever. That is a really good idea, Snarky. And then max Y is going to be our cell, or X, this is going to be the column count. Okay, so now for let X equal negative max X, and while X is less than or equal to positive, boy, I don't use less than or equal to that often in a for loop, let me tell you. But in this case, we're kind of iterating over a weird array size, or a weird array alignment. Change those to Y's. All right. Get our big list ready, which we're going to return at the end of this. Our new tile is going to be, it's going to have a tile X of X. It's going to have a tile Y of Y. That's actually it to start with. So actually, let's just one line that, because that's a very small object. Ret dot push our tile. That's it. That's how we generate a new mesh, a new clean mesh. Is the hat allowed to go on water? Let's say yes. Let's say yes. I think that could be interesting. Yes, I did see that. So Jen's idea is potentially some kind of late game or mid game research. Right now our logic for snowmen is they just pick the closest penguin and they attack it. But if the snowball is in the air and the penguin dies before the snowball connects, basically the snowball is wasted. So how to deal with that? Gwen's idea was that snowmen are smart. Like, snowmen get the ability to be smart about choosing targets. And if they recognize that, hey, that guy's already thrown a snowball, this penguin is as good as dead, I'm going to choose a different target instead. Which is, that's a fun idea. Challenging to implement, because we might be dealing with things like temporary damage buffs, enemies with damage resistance that gets turned on in certain conditions. It may or may not be easy to figure out whether something is a killing blow, if something is a dead penguin walking. Alright, so after generating the mesh, we have to determine if the tile is walkable. So let's see here. Calculate, calculate available tiles, calculate passable area. Blocked. Find yeah, maybe just available tiles. Instead of calculate, I think just determine, because we're not calculating much of anything. Determine available tiles. We take in the list of tiles. What we're gonna do is we're gonna loop through these tiles, and we're also gonna loop through our wall. Actually, we're just gonna loop through the walls. And eventually there might be more than one sprite. A research deal, so the amount of penguin can be overkilled by reduces each level until you get a very efficient... Ah, that's a clever way to do it. Alright, let's... first we're gonna grab our list of walls, which is sprites.filter, find all instances of snow wall. And really that's the only thing that can, currently that's the only thing that can impede movement, but maybe that changes later. Snowmen right now, I'm ruling you can pass right through. Snowmen don't block progress. Maybe eventually you can upgrade to some kind of combination wall and snowman, but it's at a higher price than either of them individually, because it grants you a resource in the sake of or in the form of real estate. Every time you build something, you're kind of cutting down your available area to build more things. Alright, so for each of those walls, once we've found all the walls, we're gonna find the corresponding tile, which is a tile such that tile X is equal to the walls tile X, and tile Y is equal to the walls tile Y. Boom, that's our tile. If tile exists, because maybe there's a chance that for some reason our code was bad. Actually, if it's not, fish. Someone did suggest some kind of fish enemy at some point, which that would require levels to be designed with that in mind, unless it just kind of flops around over the snow. Oh, and if I do that, then we have to do a whole nother navigation mesh just for that. Which actually, that's not too bad, because since we're making this an object, we could have a like a second class that's derived from it. A fish power-up. Oh no! The penguins eat the fish. No tile found at I'm going to include an error message so that this will be easier to troubleshoot if, for whatever reason, the tile does not exist. Fish, you steal fish. You can have a sprinter with a fish run into the maze, and then the next 5 penguins who eat it get a speed boost. No! But yeah, probably. Ooh, and that presents... Ooh, that's interesting because that presents suddenly a challenge of, oh, I gotta... Maybe I need to block this area off for now. Like, I need to temporarily block this whole area because this lane is gonna get just swarmed soon. Ooh, that's something else. Zombie Slicer, thank you. $5 going to Camp Horizon. What's to stop me from basically building a large maze? A kamikaze penguin. Creeper penguin? What's the game about? It is a tower defense where you are defending the South Pole from waves of penguins. And you are a magical Frosty the Snowman hat that constructs the snowman. That's it. That's the game. Kind of cool. I see what you did there. So currently we're working on trying to figure out how to make the penguins actually do pathfinding and not walk through walls. Because that's a no-no. They're not supposed to do that. They're not allowed to. Let's say I build out my maze with kind of 2 roughly equivalent but not quite equivalent paths. So that, like, let's say there's a top path and a bottom path, and the top path is slightly faster. So the penguins are all funneling towards the top path. And then as soon as they're right next to my tower, I plug it up. And now they all walk out and go all the way back around to the bottom path. Can I just, like, now unplug the top path and plug the bottom path and repeat? How do I discourage that? Maybe I just make it so you can't break down your walls? Yeah, maybe you can't destroy it. You only have the power to create. Build time. Oh, build time. That it takes a long time to actually construct things. That could also be part of it. Maybe you can only destroy in like a between wave respec time. Like maybe the game loop is very short prep window where you can set up your initial defenses and gather some resources. You know, however you want to, if you want to devote more time to gathering snow or more time to getting some quick snowmen out. And then, you know, the penguins come and you can only build while the penguins are on screen. As soon as the penguins are gone, you've got like 30 seconds, 60 seconds to temporarily respec. Walls that only last a few rounds. Ooh. Like something that's, let's see. The advantage maybe is that they're cheaper in the short run, but more expensive in the long run. Ooh, actually that's really good. Okay, actually that's really good. Let me explain what is so cool about that. A lot of these tower defense games reward you somehow for kind of scraping by with using as little resources as possible. Like, I remember in desktop tower defense from like the early 2000s, I want to say, in that one you would get interest. Like, for every dollar you did not spend during a round, you would get a little bit of interest back. So basically, the more you kind of barely cut the edge on getting through, the more you'd be set up for the following rounds. You get a little bit more. So what if on these walls, what if you've got 2 walls you can pick from? A wall that's cheap, but you're gonna have to rebuild it in 3 waves. Or a wall that's more expensive, which means less resources this round, but lasts for, you know, a ridiculous number of rounds. That might be the play there. That could be really cool. Like, it deteriorates over time. Because that kind of bakes in this idea of, well, if you can get away with less now, you'll be rewarded later. Because in that sense, yeah, you didn't get it this time. You have less money for this first round, but 3 rounds from now, you're not going to have to rebuild that wall, so you're actually going to save money overall. That works very well, actually. And I do like the idea that between rounds, you've got a moment to sell back for a very, you know, not a great return rate, but sell back units so that you can kind of rebuild some things. Yes, definitely, to show the deterioration between this nice, even, crisp snow and this kind of sloshy-looking slush pile towards the end. That's a good idea. I like it. Alright, so, available tiles. We found the tile that has a wall. And so, tile dot... Do we just want to use the distance? Just set it to -1 for now. Alright, so that's all that this does. Let's see here. Generate new mesh is what I called this one, but I think I'm gonna call this generate blank mesh. And this is just gonna be generate meshes where we actually do this, and then determine available tiles on the mesh, and then we do the next step. And we will rerun this. I'm really hoping that this is a cheap operation, even if I like really ramp up the number of tiles. Because if it's cheap enough, then we can rerun this every time you build a wall, which is perfect, because that's what we want. Every time the terrain changes, we need to rerun the mesh. Okay, so we're going to determine which tiles are available. The next step on our big thing here, whatever this is, now we need to actually calculate the distance. Calculate distance for tiles. So this is where we're going to... Oh, these need to be this dot. Duh. Rookie mistake. These need to be this dot. Calculate distance for tiles. So what we're gonna do... Well, you need critical tiles too, so it won't let you just build a ring of walls around the pole. That's a very good point. We definitely don't want you to be able to just block it in. There has to be some... some actual way through. Ooh. Hang on. I think I might have found a cheap way to figure that out. I'm okay with you, like, ringing in most of it. Like, if you wanted to wall up 3 of the 4 tiles around the center, go for it. Okay, hang on. Let me check something here. I got an idea. I need to brush this in real quick. I have an idea of how we might be able to calculate this for cheap. But yeah, Desktop Defender did something similar where you're just not allowed to fully encase the map. You have to actually leave a path. Doesn't matter how convoluted it is, as long as there is a path. If you build a wall on a tile that a penguin already decided it's going to go. Ah yes, can't build on penguins. Good point. We don't want you building on penguins. Actually, just leave that blank for now. Which for that... Ah, dang it. Oh wait, that's something different to figure out. That's not a deal with our pathing. We probably just won't let you build where a penguin currently is. Like if a penguin is currently like between tile A and B and they're bridging that gap, you can't build on tile B. Maybe you can already build on tile A though. Maybe that's okay. So let's see here. So let's say you have this, and then we build like a big, nice maze. I think this might actually work. I wouldn't have expected it to. Tell me if this makes sense. Oh my gosh, will this actually work? I think it will. Huh. Okay. Huh. I think we get this for free. The whole issue of how do you make sure you have a path. Like, let's say I'm hovering over a tile where I want to build, and I click the build button. Do I have to generate the Navmesh to check if that made this into a dead end? Or am I okay to like just, is there some way I can do that faster? I think there is. I think if I am hovering over, say, tile 5 here, I can't build in tile 5 because that means now there's no path out. But I can build in tile 6, even though, you know, that makes this whole path worthless to the penguins. They all have to go up through the top path. I think the key is 6 is not unique in my mesh, but 5 is. That rule may actually hold. That can't be right, though, can it? That's a good point. 10 is also unique as kind of a weird boundary issue. Oh, but there's going to be water. Water also has tiles generated. So even though it's not on screen, there will be an off-island 11 and 10 and another 9, actually. Oh, but that might be its own problem. Well, let's say I blanked these out. Nope, because then that changes to an 11, and so 9 is still unique. Does that work? Because I'm telling the code to make sure to use 5 tiles in the water in all directions. Don't see how that one... Oh, it's not. That's supposed to be an 11. That's me being stupid. Is that... Okay. So... If I blank out all of this... Then I can't build on 9, I can't build on 8, can't build on 7 because they're all unique. Is there any way, mathematically, that a unique distance is not part of the critical path? It's like, if I block out this 5, then mathematically, there should already exist some tile that is already 5 tiles away from the goal. There has to be. But if there was, then it must be next to an already computed 4. It must be 1 away from an already computed 4. And the only possibilities for that would be a 3, which must by definition already be closer along the critical path, or another 5. Like, you can't have a 7 and be like, ah, there's our 5. It just didn't count as a 5. This might actually work. I'm gonna try to see. I'm gonna let this. I'm gonna kind of keep that in the back of my head for determining. I'm really trying to figure out if there's some way, because this feels way too easy. This feels like a problem that should be a lot harder. You can't build a wall that will reduce another number. Yes, yeah. It can increase numbers, yes. Walls will only increase numbers. This feels like this is way too easy for the problem it solves. Like, when I was thinking about this the other day, I was like, this is going to be a pain to calculate. I'm going to have to, like, calculate these numbers, and then as you're mousing over an area... Because I probably want to do some kind of nice user interface thing where it's like, you know, like your toolbox grays out the wall if you're on a cell where you can't build a wall. And like, dang it, I'm going to have to, every time you move, I'm going to have to recalculate the navigation mesh. That can't be cheap. Maybe I don't have to. Because I was thinking, like, I bet what I'm going to have to do is, while I'm calculating the navigation mesh, I'm also going to somehow have to calculate every possible place where you can't build. If a penguin hits a complete dead end, will there be a failsafe that can ensure the penguin will go backwards? So, for instance, let's say a penguin is coming from the ocean here. He wants to go this way. But when he gets here, this gets blocked out. Is that the question? Like, what will he do to get out of this mess? Because that one, yes, that one we get for free. But there's one we don't get for free, which is kind of a scary one. Which is, I'm going to refer to it now as the penguin zoo problem. Which is, a penguin goes in a nice long maze. I build a wall blocking him in. Our navigation mesh recalculates so that the penguin now knows that he needs to go back because the mesh now says, hey, now we're going this other way. But now, before he gets out, I build another wall here. He doesn't have a navigation mesh anymore. He's now trapped. And he has nowhere to pathfind out. Assume in this instance that this is also wall up here. But then this penguin, this poor little penguin, will be a very sad, trapped penguin. And I don't know really what to do about that. I think maybe what we do in that case is, like, I don't know. The navigation mesh just calculates gibberish numbers in there. Like, it just decides, all right, now that I've computed all the numbers and directions, if there's any tiles that are left over that are not walls, then just give them whatever. Just give them all available directions. So basically the penguin will just wander randomly in that little box forever. Maybe it gets a special case flag to mark the penguin as trapped. So that if you kill all other penguins in the wave and all penguins are dead or trapped, then you win the round, and we just kind of sweep those penguins under the rug and not worry about them. Okay, but we do need to handle the penguin zoo at some point. Alright, now we're going to calculate the distance. He shows a special sprite that looks like Panic. Yes, the penguin Panic. I think that encourages trapping penguins. I mean, it's not hard to do, but it's not super useful, I don't think. Yeah, and if I say that you genuinely just cannot respec your walls, like, they melt, but that's it. That's all you get. Ooh, yeah, boss penguins. I think some enemies will probably avoid, like, ignore walls. The rare flying penguin. Maybe certain, like, massive penguin enemies. Maybe they can just destroy walls. If they get trapped, like they destroy all surrounding tiles if they get trapped. Discouraging such a thing. Yeah. Okay, hang on. What about... Let's see. If I'm going through here and I do this... And this changes to 12, 13, 14... Nah, but hypothetically there still would be some 13s out there. So it's not a special critical path. Dang it. So that one we don't get for free. We can't prevent dead ends. That one's tricky. Penguin Zoo is a game design problem for another time. Understandable. Calculate distance. For that, oh, we don't actually have a tower sprite. I think currently we're just drawing that in the middle. Let me confirm that. Draw. Yeah, we just draw it in the middle. Okay, we need to have an actual tower. South Pole. Tile 5. Does nothing. For now. Alright, so we're gonna find the South Pole. Yep, okay. If we do find a base, actually let's handle the negative first and then just fall out of that. No console.error. No base found for pathing. And then just return. So that should not ever happen. But we'll log it if it does. And then we'll troubleshoot that. So we want to find the base tile initially, which is the one tile such that tile X equals our base dot tile X and tile Y equals base dot tile Y. So that's our base tile right there. There better be a base tile. Otherwise, no base tile found for pathing and fallout. So that's our error handling for that. Otherwise, we're going to take our base tile and we're going to set distance equal to 0. Easy. And then we begin the loop, our big loop. Zombie Slicer, thank you. $5 more going to Camp Horizon tonight. Tile X, tile Y, distance, and best route is the final step. Alright, base tile is going to be, in this case, like our red in this little mock-up we made. So we need to find all adjacent tiles. This needs to be its own function. This method is one that we might change later if, for instance, we start deciding to do diagonal movement. Or if we want to have a different navigation mesh for some enemy that can do diagonal movement. Let's see here. Find neighbor tiles. We want to have our full mesh, and we want to have our target tile. And we're going to return the list of all neighboring tiles. So what that's going to look like is... what is that going to look like? Let left equal mesh dot find. Is there an easier way to do this? Absolute distance. Manhattan distance. Yeah, it seems a little goofy, but it could be helpful. I don't know. For instance, what if the flying penguins navigate based on looking for magnetic south, and you can have some kind of magnetic tower that disrupts their flight, so they have to path around that even though they're flying. The song is from Paper Mario Origami King. It's a little coffee shop music. So we're going to use Manhattan distance. So I think we can just return mesh where all right. what it is math.absolute value of tile x minus target tile x. Take that absolute value, add in the same for y, and it's got to be where that equals 1. That's it. So what this is doing, that sounds amazing. I love that idea. I have a soft spot for big red helium balloons in video games. A big fan, yes! And it prevents the penguins from traveling through that area within a certain number of tiles. So they have to go all the way around. Or it actually just really screws with the pathing and we have to really think about that. Oh, that would be a mess. Oh yeah, maybe they just get pushed and they don't even, like, they don't get a chance to use their navigation mesh there. Ooh, that could be tricky though. Because what if they get in a loop? Maybe that's perfect. They're floating along, then they get pushed up and backwards and down, and so then they start floating along and then repeat and repeat. Could be interesting. But I think this little one-liner here is just going to find the 4 tiles that are neighboring orthogonally. All right. Let search distance equal 0. Okay. What is my end goal? What is my end target? I don't know yet, so we're just going to do a while true until I figure out what that is. Search distance. I'm looking for all the tiles that have 0. They show their panic sprite. Tough to calculate, but yes. I'll just keep track of where every penguin has been. If they wind up in the same spot as they've already been, they start to panic. Just little sweat particles. And that way we don't have to reanimate every penguin to show panic. They can just start sweating nervously. Let's see here. Tiles to search from is our tiles dot filter where our distance is equal to our current search distance. So it starts with 0, but later on that's going to be like, okay, I'm searching for all tiles that are 3, and so I'll be like, okay, I found this one and this one and this one, and now I need to look from there to find the 4s. So tiles to search from, and then for each of those, all right, so now I'm looking at a specific tile, like this one right up here. I'm looking at this tile. I want to now find all the neighbors that are reachable, which is this dot find neighbor tiles of tile to search from. Okay, so now we've got our neighbors. Now I want to make sure that I'm only looking at the neighbors that don't already have a distance set. Whew. Let valid neighbors equals neighbors filter where a dot distance is null or undefined, I think. Actually, it should just be null if I do this right. let's actually define null here so that we don't have to deal with these alternate cases. Valid neighbors. These are the neighbors that we're going to set with our new distance. Let neighbor of valid neighbors. For each of those neighbors, we're going to set the distance equal to search distance plus 1. Yay! At the end of all this, search distance has to be incremented. And then we need to do one thing more here. Set routes. Okay, now when do we know we're done? When are we done? I guess when we run out of valid neighbors. If we ever get to a case where we've expanded our reach, so let's say, you know, we filled in 0, we filled in all the 1s. That doesn't show up at all. We filled in the 1. That doesn't know. What? This map is getting really messy. We filled in all the 1s. We filled in all the 2s. We found all the 3s. We found all the 4s. We found all the 5s. We found all the 6s. We get to the 6. We get to the 6, and we say, okay, find all of the valid neighbors now. And there's none. All of the 6s have no valid neighbors. At that point, it's impossible for there to be any... Since there's no 7s, it's impossible for there to be any 8s, so we're done. So maybe we are going to do a true while loop. This looks like Minesweeper randomized. It's the newest thing. Minesweeper randomizer. When that got brought up in stream, I was like this close to really quickly whipping something up that just looked like that. Like, just take a screenshot of a Minesweeper thing, throw it on a web page, and then as soon as you click it, it just pops up a box that says you lost. And just I was this close to just making that happen right then. If valid neighbors dot length equals 0, then break out of this for loop or this while loop. Oh wait, ooh, well, Let valid neighbors equals no. Keep searching. Let is done equals false. And then while we're not done, do the thing. And then if valid neighbors dot length equals 0, then is done equals true. GameCube, thank you. $5 going to Camp Horizon. I think this works. This is a little ugly with all these checks. All right, Jen, thanks for hanging out. Have a wonderful night. Thank you for the ideas as well. Hello, Hudson. We're doing well. So let me get everyone up to speed. Now we got some newcomers coming through. If anyone is really newcomer, we're doing an on-stream game dev project for funsies. This is what we got for like 2 or 3 hours on Wednesday's stream. And we'll keep doing this like every Friday for a while, probably. Not for too long. This is going to be well, I probably said that about the last project too, and that one wound up taking 6 months. So it's a tower defense game. You're defending the South Pole against waves of penguins by building snowmen and big blocks of snow and maybe some other stuff. We'll see. Tonight's project is... Oh, and you play as a magical Frosty the Snowman hat. since it summons snowmen to fight. So the idea is, when we're summoning these walls here to defend our base, we don't want the penguins to just break through, zombie style. I want the penguins to pathfind around it. I want them to go all the way around. So, here's tonight's plan. This is the step-by-step instructions on how we're going to generate a navigation mesh. Effectively, pretend that the tower, the South Pole, is at 0. Set all the neighbors of that tower to 1, and then loop that indefinitely of find any neighbors that don't already have a number that can be accessed and set them to the next number up. And then by the end of it, we should have a nice big list of numbers, and the penguins can just go to the nearest smaller number, and they'll constantly be moving towards the tower. That's the plan. Currently, the penguins are going to not move diagonally, but we may change that. Actually, I think we probably will make them move diagonally, but for now, we're just going for orthogonal movement. So the final thing we need to do on this pathing handler, which I'm now thinking we just call this our Navmesh. And let's rename the file as well. That means we need to also rename this. Oh, actually, we don't even have this one yet. That's fine. There we go. Okay, so our Navmesh. We want to set the routes for tiles to search from. We're going to basically be telling the tile which ways it can push its penguins towards. Routes is a blank list to start with. And we're going to tell it which way to go. Which is going to look like an object with an X and a Y, nothing else. So where am I going to tell it to? Alright, so I'm moving up. I'm moving up. Ah, I'm moving up. Dang. Ooh, dang. Okay. Maybe I can't set the route at that point. Because I'm moving outward. Yeah. So there's a possibility of, say, when you're on this 6, you can move to any neighboring 5 to get closer to the pole. I was hoping that I could, like, just assign these directions while I'm doing this part. Tiles to search from, 5. And I'm setting the 6. Yeah, that would be in the wrong direction. Okay, yeah, we'll have to do the routing on one extra step. Calculate distance. Calculate routes. This is the part that's going to actually tell the penguins, hey, I'm on this tile here. What are my available paths to travel? If there's only one path, then they'll know, okay, go that way to get closer to the South Pole, towards my target. If there's 2 paths, I think we'll just coin flip it and let them just pick one at random. Typically, there should only be a maximum of 2 routes. I'm trying to think if there's some situation where 3 is possible. I guess 3 could be possible without any shenanigans. At first I was thinking the only way you could do that is like lead them down a dead end, but no, you could actually have a split path and then the middle path is like very windy, and then they'd have 3 directions they could travel. That'd be a weird one, but they could do that. Is 4 possible? 4 is not possible. Right? Oh gosh. 4 might actually be possible. Maybe not. I don't know. Definitely not 5. But at least 3. It doesn't really matter how many are possible. Calculate routes. So to do this, I think we just want to look at every tile. Like just start with the first tile and just say, look, find me a neighbor that is a 3, and that's it. This may not be the most efficient way to do it, but I don't think that this whole navigation mesh calculation is going to take that long, considering how small the map is overall.
If Glay never gets defeated in Dobbs' quest and a new character has to be generated, I want to come back as a 2003 Chrysler LeBaron that can talk.
I did have to look after that was done to actually figure out what in the world TTS Lady was trying to say there at the end. But now we know. Will next session be the one where Glane is done in? You'll have to tune in to find out. Power-ups. Power-ups. I was thinking some kind of upgrades being available. Like, increase the build speed, increase the movement speed, that kind of thing. But not, yes, that's right, that's right. We actually don't have Dobbs' Quest this week. And then we have, what do you call it? Games Done Badly. You know, that marathon thing. That's coming up. For those that don't know, we're doing a gaming marathon this weekend. Not like today, but like this, you know, a week from now. Hello, Germ Dove. That's the one. That's that Games Done Badly right there. Alright, so for each of our tiles, find the neighbors of the tile using the mesh. Valid neighbors. Hyping it up at work. Excellent. Every call that comes in, it's like, hey, how can I help you? Also, have you heard Games Done Badly before we get going with your keyboard issue? I know it's the keyboard. It's not the software. Do you have to do both software support and just random, like, see more mouse problems? Okay, so you do handle the whole thing. It's not just for the soft. Oh, printers were a mistake. We're looking for, oh, okay, you only do software, but you do have to mess with people's printers, don't we all? Let's see here. We are looking for neighbors that have a distance equal to 1 less than my distance. Alright, so there should definitely be valid neighbors. Tile.routes now equals valid neighbors dot map. The x direction is the neighbor's x minus my current x. And the y is the neighbor's y minus my current y. Did I use tile y in this or just y? I used tile x and tile y. Perfect. Oops. There we go. And that's how we calculate our routes. Easy. Have the printer test out GDB flyers as test pages. All black with white text. All right. I think this is just about it. I'm gonna find out at least. Yeah, I think that's our code right there. To do zoo problem. We still don't know what to do with trapped penguins, because it might be possible to trap a penguin. Okay, how are we gonna test this now? Is there a way I can get the current mesh drawn on screen? I think there is. Let's see here. Oh, I need to actually... Oh, that would have been awkward. I need to actually push the South Pole onto 0, 0. Because that's actually a thing now. Oh, and I didn't even think about this, but right now I can just kind of go out into the water and plop a snowman down. We haven't done anything about that yet. Okay, so when I'm drawing tiles, we're gonna say after you draw the tiles, if mesh, then for let tile of mesh navmesh dot mesh. Boy, now I'm feeling like navmesh.tiles makes more sense, but whatever. For each tile within that mesh, I want to draw it somehow. I have, for each one, a tile X and a tile Y. Ice under it breaks, it falls in the water. The second penguin gets trapped, makes the second hole. 2 holes become fast travel points for the penguins. Perfect. I'm gonna love adding that kind of navigation. Tile X, tile Y. I think this is right. CTX.font. Now I gotta, hang on, I gotta look up font. Moon Rover, help me. How do I do font? ctx.font, text align, fill text. Okay. $20 fill style equals let's just say red for now. Fill text test at x comma y. Okay, what text does it say? It's gonna say tile dot distance. All right, well, let's see if that actually does anything. So what I have to do is I have to say mesh equals, no, I have to say navmesh equals new navmesh. Go. All right, a heck of a lot of nulls there. Yep, distance is null across the board. Well, that's a resounding failure, unfortunately. But at least the generation works right. 30 seconds to write, 4 hours to code. More or less. Okay, let's figure out why the mesh did not work. It seems like... Well, here's an easy thing to check. Is what if we add some snow blocks and then redo that. Navmesh.mesh.filter a.distance does not equal null. Aha, okay, it does do that step properly. So we know we're generating the blank mesh correctly. We know we're determining the available tiles correctly, but this distance calculation is not working. We didn't get a console.error, did we? No, we didn't. We got no base tile found for pathing. Okay. It's a good thing we put this error message in. Hey, Kip. Yeah, we're basically making balloons, aren't we? A more open balloons game. No base tile found? Is that what it said? No base tile found. So that's this one. That's saying we could not find a tile in our mesh that has the same tile X and Y as the base. Prove it. Base is right there. It is a good game, isn't it? Oh, base doesn't have a tile X or tile Y defined. Well, why not? It should. I give it a tile X and tile Y, don't I? Oh, it's got tile X and tile Y of 0. Okay. So in our nav mesh, he got wrecked. Is there multiplayer in balloons? Is that a thing? We're trying to find a tile in our mesh versus... Huh. It's very different from the balloons I remember. This is why most... Yeah, probably. Tile X equals tile X. Tile Y equals base.tile Y. Okay, so that should work. All right, let's figure it out. Navmesh dot tiles. Oops. Oh, it's navmesh.mesh, right, my mistake. Wait, that did find one. But that one does not find it. But when I try it, it does work. Weird. Okay, at this point, let's do a console.log of tiles.length, I guess? Are we? Yeah, we're editing the same thing. Can we get this game to be a stream category? Maybe. We'll see how good it turns out. 529, okay. Baby. Baby. Oh, she's so cute. Undefined. Oh. Base.tilex and tile Y. Is coming back undefined. Why? Oh, I know why. I did a filter instead of a find call there. So this base, that was not the South Pole object. That was an array that contained the South Pole object, but it was a list instead of the actual object. That should fix that. All right, closer. Mesh.filter at find neighbor tiles. Oh, I see it, yeah. There we go. Okay, one step closer. Mesh is not defined at Navmesh 64. Right, because there I call it tiles. I did not pick a great name, apparently. Considering I keep messing it up. Cannot read properties of undefined at 68. Dot routes. So routes is undefined. It shouldn't be. But it is. How? Oh, because we're getting it's the same issue as before. Tile to search from is... I want tile to search from, not tiles to search from. Alright, we're getting there. Still not getting a distance calculated. Looking to get the Adobe software today. Yes, they're very expensive. For most Adobe products, you can find something else that does the same general concept, just not at a professional level. People buy software from Adobe. They rent software from Adobe. That's the key difference. I've never used either, so I don't know. You know what software I miss? Windows Movie Maker on, specifically the one that was on XP. The one that was on Vista was a huge downgrade. And 7 lets you download the Windows Live suite, but that one was awful too. It's basically what the Movie Maker is now in Windows 10. I miss that very fine timeline view where you can, navigate frame by frame to get that perfect cut that you're looking for. It had shortcuts. It was a memory hog, but it did what you needed to do. A few transition effects, nothing fancy. I used that a lot back in college. All right. Why are we still not getting distance? Are we definitely not getting distance? We're definitely not getting distance. No, wait, we do have distance. But not for these three? Why not for these three? Alright, let's fix up this null situation here. Let's make it so it actually draws this on top of the tiles so we can see an overlay. That might help us troubleshoot this a bit. X and Y here. Cell width, cell height. Oh, that's why. X index and Y index. Also that, yes, okay. Yeah. Drop that. And X and Y, replace it with this. And that should do the trick. Yes. Ah! Look at that, we have a navigation mesh. Sort of. Oh! Truly foiled. Okay, so we actually do have a mesh. It just doesn't extend out in all directions. Enough. So we went 5 out, as I requested. All right, first off, let's bump this back up to a usable size. All right, that'll work. Okay, so we can see the navigation mesh now. Ooh, hang on, let me try. What happens if I lay these down and I regenerate the navigation mesh? Crap. That's not what we want. Just 0. Straight up 0. How did that happen? And how does this happen? This is unexpected. Alright, let's find the very small mistake I made somewhere. Hopefully just a small mistake. That's a weird one. Oops. Just want to kind of get this right around here so I can still see this. A miss. A strong miss. Okay, I think this is done. Is happening prematurely. Ah, yes. Valid neighbors.length of 0. Ah, I think this might be what I need. If tiles to search from is 0. Let's try it that way. First off, new mesh. That looks much better. Okay. Let's add in some walls. Regenerate a mesh. And look, this one's now at 12, because you have to go all the way around to get there. I think we just did it. I think that's it. That looks right. Alright. Do you guys want to see something really fancy, though? Oh, there's no way this is gonna work, but I have to see if maybe. Okay, do I have frame num? I do have frame num set up. Alright, this is gonna be hilariously cool if this works. Alright, so. Alright. Okay, so we can remove this. We can remove this. We can remove this. We have our X and our Y. For let path of tile.routes. Let's call it for route of tile.routes. CTX dot fill erect 0. Give me fill a rectangle from X comma Y. Let's go X minus 1, Y minus 1, width and height of 2, but offset that by, wait for it, route.x, let's see here, let offset equals frame num mod 20 times cell width, which I think is also 20, or maybe it's 40. Route.x times offset. Oh wait, no, let's divide by cell width. All right, this is gonna be so cool if this works. All right, here we go. First try. First try. You heard right. Dang it! It didn't work first try. The idea was there at least. Okay. Yeah, that's too small. Frame num mod 20. The idea is that's going to be a number that's going to go from 0 to 19 over and over again. Always exciting. It really is. And you get to use it a lot for game dev projects. Oh, I do want it to be times. Well, now it's just blinking, isn't it? Huh. Hang on. Hold on, guys. This is going to be great. You have no idea. It's going to be all worth it. That many. Oh. Got to put a divide 20 in there. Oh, we're close. We're close. Very close here. That plus, and that plus. Can anyone guess what this is going to be? Heck yes. That's it. Let's slow it down pretty significantly and change the color to green. RGB. Let's go for low opacity green. And let's actually bump up the size on this. Oh gosh, that's gonna kill the bitrate, isn't it? Alright. Tough to tell what's happening right now until I add some items and regenerate the mesh. What we have built here is the this is a visualization of the available routes, so that we can actually see the path that the penguins want to take based on where they are. DOS projection should work for Amazon. That's right. Penguin tracking. Now, what would really make this better is if I did not show... I don't think I want to show these tiles here because they have nothing coming into them, only going out. So I have the routes leading away, but no routes coming from. And I think that kind of information would be handy. Is that killing the bitrate, or is that fine? Maybe it's okay. That's gotta be killing the bitrate. I'm just kind of taking a stab in the dark and saying that probably is. Alright, next up, let's do this. Let's do some quick performance checking. T0 equals performance.now. You can also do new date in JavaScript, but new date is much less precise. Then we're going to generate the mesh, and then we're going to get time t1. And then we are going to log t1 minus t0. And I think this is going to be in milliseconds. So let's go ahead and preemptively divide by 1,000. And then also let's format that to 3 decimal places. So this will be in seconds dot milliseconds. That took 8 milliseconds. 7 milliseconds, 8 milliseconds, 9 milliseconds, 9 milliseconds, 5 milliseconds. I don't think the pathfinding is going to be too big of a deal. I think I can do that every time I throw down a new block with no worries. I'm going to comment that out so that if I ever need to do a little bit more performance testing, we have that available. But currently, not a problem. Let's see here. Let's do a final pass on our mesh. Let incoming equals, dang it, that's not gonna work. Okay, here we go. If I have a neighbor that I'm going to, then valid neighbors dot for each for each valid neighbor set okay. I don't know exactly how I want to do this now. It's like I want to trace a path from every most distant ocean tile to find the actual critical path and like flag each cell. Let's do one thing first here. Snow wall. When I generate a snow wall, actually, instead of doing it there, let's put the Navmesh code in our hat code for when we generate a snow wall. Let's not do it when a snow wall gets created. Let's do it right here for now. So this way, every time I generate a wall, it will regenerate the mesh. Okay, so here's my thing that I would like to do. You can see right now there's only one entrance to my base. So not taking a nap to try and fix your sleep schedule, but you failed. Oh, next time, Hudson. Okay, so notice there's only one entrance to my base, which is top left of the base. I don't want to see all this navigation mesh down here. Like, it's still important for it to be there in case somehow a penguin got trapped, but it is less important for me to visualize that part. I only want to see the maze, if that makes sense. I don't want to see every little bit of tiles details. I would really like to only see the traveling dots where they matter. So, I feel like the only way to really do that... What is the only way to do that? What is the way to do that? I think what I need to do... I'm gonna have to do it in like shells. Okay, I want to map every distant ocean tile as ugh. Well, this is tricky. Okay, let's do this. Let's try this. Navmesh dot mesh dot. What do I do? Yeah. Okay, so I need to be able to pick some starting point. Eventually we will actually have spawn points, and that'll make this a lot easier, but for now we don't have spawn points. And so it gets to be difficult for now. So let's do for let. Oh. Maybe we start with just. Let's just pick some starting points, maybe? Does that make sense? Min X. And max X. And yeah, I guess just for let tile of mesh where tile X equals min X or max X. Oh, no, not tile Y. For those, tile dot critical. We're just gonna call it critical for the critical path equals true. And then, while for a long time, I don't know how long, but while true, I guess. Tile.critical is true. Tile.processed equals false. Let toProcess equals mesh.filter where it's critical and not processed. I guess. Yeah. for let tile of to process. What we're gonna do is we're gonna look at the routes for let tile next. Don't worry, this one's not gonna make sense for a little bit. For let route of tile routes, let next tile equal mesh dot find we're gonna find the tiles such that tile X is equal to tiles tile X plus route dot X and all that but Y. Honestly, all of this is to get a prettier visualization. I want to just have something good to look at for the end of the day. Next tile is critical and not processed. And then after I've done that, the tile is processed. And keep doing that until I run out of tiles to process. I think this will work. Let me find out. Nope, not yet. Cannot read properties of undefined. Line 89. Oh, because mesh is the tiles. Duh. Hey, Nines. Okay, we do have that working now. So I think if I look at the Navmesh, a dot critical dot length is 276, which makes sense until I do this, this, this. That should reduce it. Still 276. How is every tile critical? Okay, that did reduce it. That's good. That's a good sign. So what I want to do is say, when we're drawing all of these, if tile dot critical, all this is gonna do is pretty up the navigation mesh. Oh, nope, never mind. Well, that sucks. Well, it works to a certain degree. Oh, look at that. Yeah, see? It looped around suddenly. Oh, look at that. It's having to recalculate the maze now. This is good. Except I don't get why it's not coming from the right. I must have missed something in this setup with the min-x, max-x stuff. Huh. Nav mesh dot mesh. How are there 529 now? Is that right? Is that supposed to be that huge? Okay, so that's tile X. So show me the last set of these. it just never gets set to critical somehow. Max X. Oh, there it is. Cool, got it. We're good, we're good. Okay, so now I should be able to set like a maze. Yes, yes, it's culling the maze now. Into a nice, pretty pathfinding setup. Yes. Look at this. Cool. What happens if I do this? Oh, yep. It all breaks. Beautiful, isn't it? Okay. So that's really good. That is fantastic, really. So there's a few things that we learned there, or that we earned there. One is when we are about to put down a snow wall, yes, we want to make sure that you can't block the only path. So we're gonna look at the Navmesh. When are we gonna build the Navmesh? We're gonna build the Navmesh pretty soon after we set everything up initially. We're gonna look at the Navmesh.mesh. Let navtile equals our navmesh.mesh.find a.tilex equals this.tilex and a.tiley equals this.tiley. If navtile, which there better be a navigation tile, we can only do it if there is a tile there, and also let is navtile critical. Does leave path open. That's what we want. To figure out if this leaves a path open, let nav distance equals our navtile dot distance. Now let's just we don't need a separate variable for that. What we're going to look at is, does any other tile have the same distance as our nav tile? It has to be at least 2 tiles with that distance. If not, you can't block it in. That's the plan. All right, let's see if that works. All we're looking to do is see if we can create an impenetrable force field. We should not be able to. Dang it. We can. How did that happen? Dang it. Alright, look at this again. Dang it, I know exactly why. Because it was nice and open. Alright, this was our original proof of concept. Where I was like, no, it's impossible to have a... Like, if I had another right here that was also 2, and I said, block this one out, but 2 was already a dead end, I shouldn't be allowed to block this 2 out. Because this 2 doesn't really count. So I think we've got to find, are there any 2s that are on the critical path? Ooh. I guess it doesn't have to be the critical path. Have a good night, Hudson. Okay, we gotta find another tile that has the same distance and is on the critical path, I think. I think that'll work. Here we go again. Okay, I can't block it. Can't block it. I can block this one. Can't block this one. All right, now we're in business. It's preventing me from blocking any of these. I can't place it any of these, which is exactly what we want. That one's okay, because it still leaves a path. These are not okay. All right, we did it. That's done. Oh, almost there. Now we just need to make the penguins follow the path. All right. Penguins were super easy to program initially. In fact, they don't even keep track of their tiles, do they? Tile X and tile Y. Alright, so how do we do this? The penguin is going to move towards a target tile. That's what tile X and tile Y really represents, is the target tile. So let's see. Let is at target. Are you at target? Which is basically this dot tile X times, so it equals our current X coordinate and tile Y, current Y coordinate. If we are at the target, then we need to choose a new target tile. And how do we do that? With our navigation mesh. Let nav tile equal navmesh dot find a tile. We're finding a tile. Tile X equals this dot tile X, and tile Y equals this dot tile Y. We're gonna have some pathfinding penguins shortly. If nav tile, then do a thing, else throw an error. Penguin can't nav. So if we have a nav tile, then we have a list of routes where we can go to. Now, if routes.length, let's just generate a random number no matter what. Let route equal math.floor of math.random times routes.length. Routes sub that. Again, we're gonna do an error check here, just to be safe. Penguin can't find route. So we have a route which contains an X and a Y delta. So this dot tile X plus equals our routes X, and similar for Y. And there we go. We have updated our target tile. Whew. Now is where we want to be able to move diagonally at the same speed that we move orthogonally. Oh, we're almost there. So we have our target X is tile X. No shiner. Cell width, and our target Y coordinate is our target tile times the cell height. And from that we can gain our direction. Did I do this for the hat already? Where did I use a theta in this code anywhere? Snowball speed. That's where I did it. Okay. So target Y, target X, boom. Oh, and I need to check distance as well. If distance to target distance to target squared, but whatever. Oh yeah, that's got to be speed there. If it's that, then just set this dot X equal to our target X, and this dot Y equal to our target Y. Otherwise, move a certain amount of speed towards our target. Okay, does that work? Do we have pathfinding? No. Penguin is not defined. Penguin is not defined. It's snowman. Snowman? Did I add penguin code to a snowman? No, I must have just done something goofy in this code here, right? What? Uh-oh. Why does it think penguin is not defined now? What did I do to my penguin code to make it so bad that it just broke everything? Alright, this is an easy fix, or an easy check. No. Removing... Okay, so that's not what it was. What did I just change that broke all this? Index still defines penguin, right? Yeah. Penguin is not defined. It seems very convinced. Did I? Oh, I bet I know it. I bet I know what it is. Very top. Yep, there it is. VS Code trying to be helpful. All right, so now here come the penguins. They're making a straight. They're making a straight shot now. Oh no. They're occasionally going to randomly move towards the middle. Yes, yes, yes. All right, so now if I start building a wall, the penguins are going to want a path around it. Yes, they are. Okay, we're almost there. The last piece, I think. Navmesh, neighbor tiles. Currently, navigation mesh is looking for orthogonal movement. That is to say, up, down, left, right, nothing else. So we're going to comment that out. And change it to diagonal movement allowed. That's right. Oh, look at this little mesh going on here. Oh, but the penguins tend to be okay with going up as long as they later go down. So that's not super cool of them. And they should be able to navigate through diagonals. Yes, they can navigate through diagonals. That is expected. I know why they're wanting to go up, like away and then back. It's because in the current code, all neighbors are equal. It's like, even though it takes longer to travel diagonally like that, it treats it as being equal because it's tile-based movement. Oh, that's tricky. Is there a way around that? Because technically diagonal should get a greater distance. If it is possible to like cheat that out in the calculate distance phase. Yeah, we just look at all valid neighbors and increment search distance by 1. Maybe I could do something like, if if neighbor.tilex does not equal tile to search from .tilex, and same with y, this is gonna be really cheaty, then neighbor dot distance plus equals half a tile. Well, now it certainly wants to go only straight, and a lot of penguins get stuck because they're no longer on a critical path. Yeah, okay, that's not good. Huh. Alright, well that was a bad idea. Alright, diagonal movement is an issue that we will return to. For now, we have no diagonal movement. Oh well. For another time. Alright, I think that's it. That's the stream. We added a navigation mesh. I'll check this code in so it's available. Does that command work now? It does. this diagonal problem is going to be a little bit more of an issue than I was expecting. Because I think I'm getting a lot of stuff for free that I don't get for free if I'm doing diagonal movement. That is tricky. We'll figure it out, though. We'll figure it out. But the important thing is we have a navigation mesh that actually works. One thing that I think would be nice is if we make this a little bit less opaque. So it's like you can technically see it, but you know, just a little bit more subtle movement going on there. Well, now I can barely see it at all. That's still pretty bad. Well, whatever. Okay. Well, we've got something at least. Yeah, the penguins just want to get away from the center. They're not taking the shortest path because I'm telling them that all 8 directions are the same, but they're not all the same. All right. Well, that's that. Everyone, thanks for hanging out and watching me do all this weird number crunching stuff. Streams coming up. I don't actually know what is going to happen Sunday or Monday, because Monday is normally Dobbs Quest, and we're not doing Dobbs Quest this week. Wednesday, Mario Maker. Friday, back to more of this. And then, on Saturday and Sunday, there's going to be a marathon going on featuring some of your favorite streamers from the extended Dobbsiverse. So be sure to tune in for that. And also, Germdove will be there. All right. I'm gonna stop rambling, and I'm gonna I'll pull a shiner, and I'll just hit the end stream button, right? No, I wouldn't do that. Goodbye.